Good afternoon everyone, I am Mr. Ish. Thank you for joining me for this video where we are looking here at this compound which has a certain element of stereochemistry in it and we have to name it appropriately. When you're looking here at this compound you have to understand there are certain carbons here which have chirality to them. They are chiral carbons. What are the chiral carbons? Any carbon which has the valence of 4 met and those 4 items stemming from that carbon are different substituents, that's a chiral carbon. This is not a chiral carbon. The word here being chiral, it's certainly not chiral because here you have 2 hydrogens sticking off from it. Here you'll have 3. So these 2 are not chiral carbons, but this right here is a chiral carbon. And this is as well. Look at these carbons, you have different substituents. When you look over here at this carbon, you have to name it appropriately. Likewise, this has to be named appropriately. What we have here is a 4 carbon chain. 1, 2, 3, 4. You have an alcohol here and it would be numbered from here 1 and this would be number 2, this here would be number 3 and this 4. We know we're looking here at a butanol, but we have to name it properly. So let's put that aside. It's a butanol. We don't even have to say 1 butanol because the hydroxyl is on carbon 1 and it's assumed to be carbon 1. Now let's talk about the chiral carbons and naming them appropriately. Let's focus here on this carbon and we'll name this first. When I'm looking at this chiral carbon, it looks something like this. You have a bromine sticking out. The shaded here represents some item is sticking outside the plane of the board, and the hydrogen here is represented in terms of dashes, so it means it's behind the plane of the board. I have a certain item over here, all of this I'm going to call that R. I have a certain item here, methyl, I'll call that CH3. This is what I have. Now we have to prioritize these. When you prioritize them, you're looking at the atoms directly attached to your chiral carbon. Here's my chiral carbon. The atoms directly attached are bromine, hydrogen, carbon, and then a certain R. But this certain R, which is your rest of the molecule, is still a carbon. The carbon is directly attached to it, but then directly attached to the carbon is a chlorine. Here directly attached to your carbon, and we can represent it in a way so you can see it better, is a bunch of hydrogens, but I'm only writing 1 hydrogen. We're going to classify this as R or S. You have to prioritize based on the atomic numbers. This is the highest atomic number, it's 1. Now you have a tug of war between these two. They would be seemingly the same, but they're not, because this has a chlorine attached to it, so it becomes priority number 2. This has a hydrogen attached to it, becomes priority number 3. This is number 4. Remember again, the shaded region here represents the atom is pointing towards you, it's closer to you. The dash means it's further away from you. These basic lines, solid lines, represent they're in the plane of the board or the plane of the molecule. Now you have to prioritize it. If your numbering from 1, 2, 3 and 4 is clockwise, then you're looking at R. If it's counterclockwise, it's S. It's easiest when your highest priority molecule is pointing towards you and the lowest priority is pointing away from you, because all you have to do is just do your arrow and your designation is exactly what your arrow shows. I'm looking at a priority which is going like this. 1, 2, 3 and 4. And what does that mean? It's counterclockwise, so we're looking here at something which is S designation, so that's done. Now what we do is go to the next chiral carbon, and that's this. Now in this particular case, the hydrogen is pointing towards you and the higher priority atom is away from you, and that makes it difficult to assess, but we can still do it. When you look at this chiral carbon, you're looking at something which looks like this. Here's your hydrogen pointing towards you. Here's your chlorine pointing away from you. Then you have here a CH2OH, and then here you have your rest of the molecule. But the rest of the molecule is really a carbon here directly attached to your chiral carbon, to which is attached a bromine, and this is what I'll do. I'll make this representation even better. I am looking here a carbon to which are attached hydrogens, but to that is also attached the oxygen. Now let's prioritize it. You know hydrogen is number 4. You know chlorine here is number 1. It's a tug of war between these two, and you know this beats it because bromine is higher than oxygen. This is a 2, this is here a 3. Now you can't simply just do your arrow like this and think you're right, because you have to always make your lowest priority item away from you, not closer to you. Here it's closer to you and your highest priority is away from you. It has to be flipped, and you have to remember that. You can't just do a simple arrow designation here, it wouldn't be right. Again, because your hydrogen, your lowest priority is pointing towards you, it creates an issue. What do? You can picture yourself as standing behind the board, and then from behind the board you're looking forward towards the item, the molecule, you see. Because if you're literally standing behind the board, then the chlorine is pointing towards you and the hydrogen is away from you. This is some of those mental tricks you can do in your head. I am literally standing behind the board. If I'm standing behind the board now, the chlorine is towards me, and then I redraw my molecule. Because I'm standing behind the board, the chlorine becomes closer to me, but the hydrogen moves behind. Now what do? This part right here is my left side of the molecule, this part right here is my right side of the molecule. If I'm standing behind the board, what was left has now become on my right side of the body. What was right has now become on the left side of my body. So this is what I end up seeing. I have a C and a Br. The left side becomes a right, and the right side becomes a left. This again requires practice and mental imagery. You put yourself behind the board and picture how you would look with the chlorine towards you and the hydrogen away from you. Now you do your priority. I know this here is 1, this here is 2, this is 3, and that's 4. A simple rotation over here of curved arrow demonstrates that you're looking clockwise, and this right here must be R. Again, remember, when your higher priority atom is towards you, it's easy. When your higher priority atom is away from you and the lowest priority is towards you, it's difficult. You have to do mental imagery or mental manipulation, and you get your designation. I have an S here, I have an R over here. Now what we can do is name it. The naming rules are everything with regards to alphabetical and numbers and all of that. But then we'll throw in the R and the S. This is how we'll name it. I have a bromine here on carbon 3. Because this right is my carbon 1, this is 2, this is 3, and a 4 chlorine on number 2. What comes first alphabetically? B for bromine or C for chlorine? It's bromine. So we are going to say 3 bromo. This bromo, B doesn't have to be capitalized, but it can be. Then we'll say 2 chloro, because again B comes before C. For standardized purposes, let's lowercase it. I have a 3 bromo, 2 chloro, then I have here a butanol. Because I don't have to say 1 butanol, the hydroxyl is on carbon 1. Now let's bring in these designations. I will write my designations as this. I can do exactly in the direction I'm seeing here, I can write it, or you can do it numerically, it doesn't matter. I'll do it numerically. I have here a 2R, comma 3S. You can, if you want, do 3S, 2R, but it's preferable if you do numerical here. In numerical order, 2 comes before 3. This compound here is 2R, 3S. Carbon 2, which is a chiral carbon, has an R designation. Carbon 3, which is chiral, has a S designation. As we see, 3 bromo, 2 chloro, butanol, and it's done, and it should be right. Thank you for watching.